This is an RNZ podcast.
Kia ora, hello and welcome to Elemental from RNZ. I'm Alison Balance.
And I'm Allan Blackman from the Auckland University of Technology. Elemental is a podcast in pursuit of profound
and trivial
chemical facts about the elements of the periodic table. We are doing it alphabetically, which means this episode, episode 51, is about neon.
Neon signs instantly come to mind. But before we get ahead of ourselves, may we have the basic data, please?
Absolutely. So neon from the Greek neos, meaning new. So, chemical symbol Ne, atomic number 10, which puts it at the very top right-hand corner of the periodic table. It's the first p-block noble gas, and it's the first element with a true octet of electrons.
So it's feeling quite satisfied.
It's very satisfied, very, very happy. That makes it a noble gas, in fact, which means that it should be unreactive, and it most definitely is. There are no known compounds of neon. Okay, where do we find it on Earth? It's actually found in the air, where it is quite rare. Ouch.
Getting poetic there.
I know.
See how many other rhymes you can throw in.
No, you don't want that.
Okay.
So, rarity, it's only found around about 18 parts per million in the atmosphere, which is surprising because when you go to the entire universe, it's in fact the fifth most abundant element in the universe. So the reason that there's not a heck of a lot of it on Earth is because it's less dense than air, and so therefore it just goes up into the vacuum of space.
That's like helium, isn't it?
Yeah, indeed. Helium also we are suffering shortages of. As I say, it's a noble gas, and it was first isolated in 1898 by Ramsay and Travers. Certainly Ramsay we have talked about before because he was the discoverer of all the other noble gases except radon. So they got this from the fractionation of liquid air. So they were sort of distilling liquid air in parts. And one part they found that when they put an electrical discharge through this new gas that they found, they were amazed by the fact that they had a brilliant red glow. And anybody who's ever seen a real neon light glow will know what it's like. It is, in fact, the most intense of all of the noble gases. And Travers later wrote, and I quote, "The blaze of crimson light from the tube told its own story and was a sight to dwell upon and never forget." Very poetic, that.
Where does the name neon come from?
Okay, so funnily enough, the name was suggested apparently by Ramsay's 13-year-old son, but the name he wanted was novum, which is the Latin for new, but Ramsay went with the Greek derived from neos, Greek for new, and he got neon.
That's pretty unsporting, though.
Yeah, a nice little anecdote, though. And as you've also alluded to, the glow gives its name to neon lights or neon signs, and they were first popularised, in fact, in 1910 by a Frenchman by the name of Georges Claude. And that is how the company Claude Neon got its name.
So, pardon my ignorance, who or what is Claude Neon?
This was a company established in 1914, and Claude Neon is the longest operating signage company in Australasia.
Oh, well, I make a real point of ignoring billboards and advertising, so that's why I've never heard of them. Sorry, carry on, please. Neon lights?
Okay, so as I was saying before you interrupted, neon lights are only red, okay? So people will talk about neon lights being this, that, and the other colour. No. They are only red.
So how do we get neon lights in colours other than red then? And I'm thinking that Times Square, for instance, in New York, it's a multicoloured riot of neon lights.
Well, not neon lights really. You get it from the other gases. So hydrogen will give you a nice sort of purple, helium gives you a nice yellow, carbon dioxide white. All the other elements give their own colours, and this is what we see in so-called neon lights. And you said Times Square there, and that took me back to an anecdote from the wonderful Oliver Sacks in his truly brilliant book, Uncle Tungsten. If any of you have any interest in chemistry whatsoever, which you obviously do because you're listening to this, you really need to read his book, Uncle Tungsten. It's a fabulous, fabulous read. And he talks of himself in the post-war years as a 12-year-old walking through Piccadilly Circus with a pocket spectroscope and looking at all of the so-called neon lights there, and still being as thrilled doing that sort of 40, 50 years later when he walked through Times Square as a much older guy, again with a pocket spectroscope and just being wowed by all of these different coloured lights that he saw in his little spectroscope. Really, really nice story.
It's a delightful story. I like Oliver Sacks.
Yes,
Shame he died recently.
I know.
By the way, how do neon lights actually work?
So a neon tube is a sealed glass tube, and it's got metal electrodes at either end, and it is filled with a particular gas at a very, very low pressure. Then what we do is we put a rather high potential of roughly several thousand volts across the electrodes, and what that does is to ionize the gas in the tube, and by ionize we mean it takes away electrons. When it does that, we get the emission of coloured light. And this is basically the same sort of thing that Ramsay and Travers used to isolate neon in the first place and show its amazing crimson glow.
Ah, thanks. Of course, neon is useful for more than just bright red lights, eh?
Oh, yes. So neon was instrumental in both, I guess, the realisation that elements could consist of more than one stable isotope, and as a result of this, also the development of a thing called the mass spectrometer. Now, isotopes, mass spectrometers, what are these? Well, let's discuss this very briefly. We could talk all day about this, but in 1913, there was a guy by the name of J.J. Thomson, or in fact Sir J.J. Thomson, as he was by then, and he was Ernest Rutherford's old boss, and he found evidence for the presence of two isotopes of neon, so neon-20 and neon-22. And the way he did that was by passing cathode rays obtained from neon, using sort of the apparatus above, through a very strong magnetic field. And these ions would bend in the presence of a magnetic field, and this is the same principle as used in a mass spectrometer. So what's an isotope? An isotope is an atom of an element that has got the same number of protons but different numbers of neutrons.
I think we talked about them a long time ago.
Yes.
As being like different flavours.
Very, very probably, yes. So this was kind of interesting because there wasn't any evidence for stable isotopes back in those days of J.J. Thomson, and so he thought that the experiment must be wrong or that the neon must be impure, so he ended up sort of purifying the neon, but it always gave the same results. And then another colleague of his by the name of Francis Aston sort of refined this method, and then as a result of this he ended up with a Nobel Prize in Chemistry for 1922 for the discovery of isotopes. A rather tragic aside to this, actually. So his family, this is Aston's family, put his Nobel medal up for sale in 2016.
What?
I know. You look for this on the internet. It's all over the internet, but what I can't find, unfortunately, is what actually happened, whether it's sold or not. But certainly the auction house was putting a price of between £200,000 to £400,000 on this. So Nobel medals are really very expensive beasties, I guess.
It does seem a bit odd buying someone else's Nobel Prize medal rather than winning it.
Well, it's the next best thing, I guess. If you can't win it, buy it.
And you would have thought the family should have been really proud of that prize-winning ancestor. Never mind. Any other uses for neon?
Yes, like a few of the gases, we find that neon is used in helium-neon lasers. It's also used as a low-temperature refrigerant and goes down to quite low temperature, around about minus 240 degrees. And at that temperature, it's in fact much more efficient on a volume basis than is helium, which we normally use as a refrigerant. And also for you, Alison, being a diver, it's also used as a diving gas, apparently because it's less soluble in bodily fluids than is helium. So you don't get the bends as easily, I guess.
Oh, I think I just dive with compressed air, but I do dive with people who seem to have fancy mixes of all sorts of chemicals.
And apparently one of the good things about neon is that you don't get a funny voice, apparently. So if that's important. Given, as I said at the start, that neon looks to be even less reactive than helium, so in other words, it's the least reactive of all the elements, some have suggested, in fact, that the periodic table needs to be redrawn, so that helium should be in group 2 of the periodic table rather than group 18. It should be next door to hydrogen, and that would then make neon the first and most unreactive of the noble gases.
Do you have an opinion on this, Professor?
I can see both sides of the argument, as I often do.
What's today's interesting fact?
Okay, I think this is kind of interesting. So neon has got the smallest temperature range at atmospheric pressure over which it exists as a liquid. So it goes from a solid to a liquid, and then from a liquid to a gas over a range of only 2.5 degrees Celsius. Amazing.
So it almost, but not quite, sublimes from solid to gas. Well. And on that note, we are finished for this episode. If you'd like to follow along, if you aren't already doing so, then you can either listen to us online at rnz.co.nz/chemistry or find us as a podcast. Oh, and keep an eye out for more podcasts from RNZ. There are plenty on a wide range of topics and not just chemistry.
So thanks for your company, and we're back next time with nickel. But until then, it's cheerio from me, Allan Blackman.
And me, Alison Balance. Bye for now.